just simply electrifying an airplane or just simply electrifying a helicopter is not a new capability. It's a pre-existing capability, it just costs more to run. So for us, it's really about, hey, what new capability does the electric architecture enable? You do access like a helicopter. You do cost like a fixed wing. You do payload and range like a fixed wing. You take noise out of the system and you do it safely. One of those 6 things was what always killed every other effort to bring aviation closer into communities.
Hey, welcome back to the Aerospace Executive Podcast. I've been looking forward to this one for a long time. I've got Mark Allen on with me. Mark is the CEO of Electra Aero. Electra's got a really, if you go to electra.aero on their website, it is a really cool hybrid electric platform, cutting edge. Mark's got a great background. Looking forward to just talking about what you guys are doing in the eVTOL, short takeoff and landing, next generation aircraft space. So thanks for coming on, Mark.
Thanks for having me, Craig. I'm glad to be able to do the conversation with you. And yeah, there's a lot to talk about.
So there's a lot of obviously a lot of development in the area, and you guys are kind of pioneering. Been around for a little while. Talk about what you're doing, what's going on. Talk about the product and how you're changing the market. Where you see it all going.
Yeah, you bet. Look, it's a great moment. There's just so much energy right now. You can feel the inflection moment that's happening for advanced air mobility. A variety of systems are becoming real. Capital is showing up with the real intent to support some of the leading players. And I think the customers, the operators, are starting to really think through the use cases. A ton of support and help from the government. The president's executive order this summer, which has launched this integration program for advanced air mobility systems. All of these things are coming together, and we're kind of just sitting right in the middle of it. The timing's worked out very well. We've been around for about 5 years. The company was founded in 2020. It was founded with a mission to bring sustainable air travel to communities everywhere. Our vision is to do that by using the very unique aspects of electric propulsion to create a new system that is still entirely wing-borne. So just an airplane, as I tell everybody, just an airplane. But it's able to get in and out of extremely small spaces. It needs 150 feet of ground roll for takeoff and for landing. And the ability to get in and out with just 150 feet of ground roll, while also being a very quiet system because of the electric propulsion, enables it to suddenly fly a ton of helicopter missions, but it's dirt cheap, right? It costs what a fixed wing costs or less. It flies as far as a fixed wing, carries the payload of a fixed wing, flies at the speed of a fixed wing, has great fixed wing safety. So it just opens up this mind-bending set of possibilities about where you can have a platform that operates with the access of a helicopter, but all the other value points of a fixed wing, and really take advantage of the modern technology enablement to bring that platform to bear. And frankly, also then to bring passengers to it through the kind of rideshare tech that can find 9 people that want to go from point A to point B without necessarily having to be tied into congested hub airports. That's what it's all about. We call it the ultra short because of that ultra short landing and takeoff capacity. And we're excited for it to enter, to open a whole new era of air travel for people and cargo through the air.
Yeah, so when we first talked a couple of weeks ago, you're the first person in the advanced air mobility space to actually talk about what really matters: payload to range.
Right. So, I mean, come on, it's like motherhood and apple pie for an aerospace guy. Payload range, like it's one word. I don't even have a dash between the two.
So you got right now. You're talking about 1,000 miles, 1,000 pounds, 1,000 miles.
Yeah, that's right.
Obviously, a lot of versatility. I mean, you can think about, and I take it unmanned or manned, either one.
Yeah. So look, let me take those. They're 2 really important topics. So let's take payload range first. Think about your classic payload range chart. Starts high on the left, curves down to the right. So high on the left for us is really the commercial space we'll play in. That's where you'll see us take payloads of 3,000 pounds, 300 miles. So think that 3,000 pounds encompasses 9 passengers. Each one's got 50 pounds of bags. Golf clubs, skis, going somewhere fun, right? Bottom side of the curve, it's 1,000 pounds traveling 1,000 miles. That's a military mission. we get one curve with dual use. And so that dual use case fit for this airplane is something that's really important. It means that it's going to be subscribed into by the Air Force and other services in the early going. And then it's also going to build market share in the commercial space, both replacing existing 9-seat aircraft, but also then moving into this very important segment we call direct aviation. It's all about getting you where you are, somewhere close to where you live, work, and play, an access point, an ultra short access point, and taking you to another access point somewhere else. So think about multi-pad vertiports, heliports. Think about, parking lots at abandoned shopping malls. You give us a couple hundred feet, and we've got an ultra short access point that suddenly becomes a portal into the air for our passengers and for our operators to create business around it. So that's where payload range really plays, because you can go between New York and DC, you can go between Sacramento and Mendocino, you can go between Palm Springs and LA, between Santa Monica and Las Vegas. All these routes that are an absolute bear, right, to manage, whether it's by car, by train, or by plane. They all have their own constraints that really make them these nasty 3 to 5 hour trips. And we turn them into 45-minute to an hour, 15-minute flights. That's the beauty of the direct aviation piece of it.
Capital cost, if you obviously capital cost being a big driver of economics.
Yeah.
Goal sale price. Where do you think you need to be on a sale price to make the economics work?
Yeah, it's a great question. So two things. I got to say first that we really look at the full life cycle value. Okay, because at the end of the day, the capital cost, it's a portion of the cost, but it can range anywhere from 15 to 25% of full life cycle value. There are a lot of other costs, crew, fuel, maintenance among them. And the beauty of the electric propulsion system is a radical reduction of the maintenance cost. I mean, we're talking about electric engines at the edge of the wing that can come on and off in 45 minutes. I mean, you never heard of this kind of changeover. And so the swappability, that part of the propulsion plant really matters. Obviously, you have very different maintenance concerns. Think about the difference between maintaining a Tesla and an internal combustion engine vehicle, right? You take a lot of the movement out of the dynamic system with that electric propulsion, and that just makes for ease of maintenance. So we see a significant reduction in maintenance costs, and there are a lot of other reasons that drive it as well.
No more hot section overhauls, right?
Yeah, I mean, look, we'll still have some because we'll still have the turbine that's part of the turbo generator. Remember, it's a hybrid system, so the turbine burns jet fuel. The generator that's attached to it produces electrons. They charge the battery, they charge the wings. The difference is this turbo generator, you remove from it all the thermal variability that a turbine normally has on it, right? Because for a hybrid system, we're going to take the thrust level to a single setting, and it's just going to sit there, set it and forget it, as opposed to traditional turbine is operating up and down as the airplane is climbing, cruising, descending. So you're all over the place. You get this thermal variability that creates stresses, of course, on the plant. You also don't have any prop loads going directly into the turbine like you normally have on a turboprop, right? Because you're not producing the spin of a propeller cutting against the air. You're just spinning the shaft to drive the production of electrons that come out the other side of the generator. So you're able to really change the physics around the turbine in a lot of ways that also contribute to the greater cost competitiveness of this entire vehicle versus other 9-class airplanes. And then the other thing, Craig, and it's really important to say this, you're talking about an airplane that's competing against both helicopters and fixed wings. And anybody in the VTOL business, whether a helicopter or an eVTOL, it's just super expensive because it takes a lot of power to take off vertically. And so we're able to get into and out of, 80% of the spots they go into and out of. And we do it always wing borne. And being always wing borne, we have radically lower costs. So, think about a Bell 429, and on a per seat basis, we see CASM, cost for available seat mile, at around $260. Okay, we see eVTOLs with cost for available seat mile around $1.90. So their eVTOLs are less than the helicopters. They take a big chunk of cost out, right? 70 cents comes out, but they're still expensive. And that $1.90, that includes in it the battery replacement costs, which all of industry understands are real and have got to be accounted for. Then you drop down to a Caravan. And Caravan kind of competes in the 80 to 85 cents range on a CASM basis. So you can see a huge gap, right, between fixed wing and helicopter. And because what we're building is just an airplane, just a fixed wing airplane, we're going to put that price, the cost, the chasm, right at or under that Caravan pricing. So you're going to see us in the 70 cents on a chasm basis. That's huge. So we'll be competitive to the fixed wing because we'll have a lot more capability, but we'll also be wildly underpriced to everything that's vertical, eVTOLs or helicopters. That's where the market gets really fun.
I love, like I watched the videos. I'm like, yeah, you're on, my initial skepticism of, all electric aircraft was pretty high.
Mm-hmm.
And now I see the hybrid electric. I'm like, okay, I'm getting it. I'm getting it now. And it probably is it is the future. Yeah, you got 2,000 orders. I was talking to Bob Waltz, the new vice president of flight operator, the new COO of JSX Airways yesterday, a good friend of mine. I know the guys at Surfer. You got 2,000 orders out there right now. Plus, I'm sure the DoD is looking at it as well. Is the market finally coming around and really saying, yeah, okay, we're onto something here? Or are they still looking at it like, hey, it's a little bit VC, prove it to us?
Yeah, look, we're still early. Okay, we all recognize that. We've been flying our prototype for 2 years, so we got a good track record behind us, and now we're building the product itself, right? So it's a transition from prototype to product. That's an early stage in many respects. On the other hand, what I know about customers is they care about value and capability. And so what we spend a lot of time doing is really, thinking about our system, our design, and how it creates value for the customer, just wildly customer focused. And I think that when people began and advanced their mobility, there was so much excitement around just the fact that we could do new things, that sometimes we did new things without describing what the new capability was. And just simply electrifying an airplane or just simply electrifying a helicopter is not a new capability. It's a pre-existing capability. It just costs more to run or you can't go as far because the energy density of batteries just isn't anywhere close to jet fuel. It's like, a 40x difference. So for us, it's really about, hey, what new capability does the electric architecture enable? And as we define that and the customer sees that capability, it all comes together. And so our customers go, wait a second, you're telling me you've got this balanced algorithm. You do access like a helicopter, right? You do cost like a fixed wing. You do payload and range like a fixed wing. You take noise out of the system and you do it safely. And they start scratching their head and they're going like, one of those 6 things was what always killed every other effort to bring aviation closer into communities. We had these, helicopter airlines in the 1970s, right? New York, Chicago, LA. Remember those? Of course you do.
Yeah.
And they all failed for 3 reasons. Cities started to enact noise ordinance because they hated the loud noise. Yeah. We had a terrible set of tragic accidents that were all front page news and really pushed people away from helicopter use. And they were really expensive, so we had a small market to start with. And so they were all out of business within a decade. But there was that idea, right? People knew they wanted to go use the air to travel people and goods from close to where they were to close to where they wanted to go and avoid the thicket. Today, 30 airports across the U.S. cover 70% of all the air travel, all the times that people and cargo moves up in the air, they're going through 30 little teeny spots. That's a heart attack. Right? That's a coronary, man. So the idea behind direct aviation is create a mesh network where people have access points to the air, portals to the air all over the place. And yes, the airplane still operates at airports, but beautifully, you can look at an airport like Charlotte or Newark. These things are hugely constrained. Operators can't even meet the full demand of their passengers, so they're throttling back. And so we come in and say, well, look, we can use our airplane to actually enter that airport environment through a totally deconflicted airspace map. We can use deconflicted ramp and deconflicted gate space because we can approach and land like a helicopter. We can use courtesy vehicles to move people over to main gates or to lounges. And there's plenty of pavement. Airports don't like pavement. That's not the problem. The problem is just IFR into the main centerline runways. But when you start using ramps, taxiways, and cargo flats and places like that to land, all of a sudden there's lots of pavement to use, and you can have a bigger set of catchment across both the geography and the number of passengers for the airlines. So these things they're mind-boggling for the customer. They go, that's a capability. I couldn't do that with just normal turbine propulsion.
I look at it a lot of ways. I look at FedEx feeders. I look at, the last 200 miles of cargo. I look at Aspen to, Denver to Aspen and avoiding the I-70 corridor. I look at, you talked about to Newark, but I'm also sitting here thinking about the military
Yep.
applications as well,
Yep.
cargo transport, but also, ISR or, other, just hanging some systems on and letting these things go.
Yeah, look,
Um,
the military, Craig, you're spot on. I mean, the military is a very important use case because it starts with the acknowledged need for runway independence, runway agnosticism. Right? We all understand that in a peer or near peer conflict, the ability of a peer to impact our runway environments,
Mhm.
especially if it's an away game, is a serious issue. And you've still got to get fuel, spares, munitions, food into troops that are in places that you may not be able to access with an airplane in a traditional runway configuration. Or just get
Mhm.
the runway repair crew in. Like, how are you going to get them in when these environments might be 500 miles apart across wide open water? So the range gets really tough for a helicopter. But with our airplane, you can fly 500, drop in, offload the cargo, do runway repair, get back on, fly home another 500 with zero infrastructure, right? You do it all one leg because that's your 1,000 miles with 1,000 pounds. So the ability to solve runway agnosticism and runway independence for the military is very important. Then the use case just grows, and that's to your point about ISR. This is a 600 kilowatt generator. So when it's on the ground, it can power comms, mobile power units, mobile command stations. It can power and charge up drones and start them. We did a couple of weeks up at Griffiths Air Force Base with the 174th wing out of the Air Force and attack wing out of the Air Force. And we went through a bunch of operational scenarios with them, air drops that we simulated, flying into inaccessible areas. And one of the things we did was charge starting MQ-9s, right? So they stood in as surrogates for the potential future CCAs, especially those that are doing vertical takeoff and landing. You got to get a charge start to them, right? They don't ordinarily charge start themselves. So we did that to demonstrate the usefulness of it. Now you can take that same idea of expeditionary power and just put it up in the air, right? Because while you fly this airplane, we can protect about 5 to 6 times the available power for mission suite as you'd have on an F-18 Growler, the EAG, right? That electronic attack and warfare system. So there's a lot of power, and you can use it for a lot of things, and that's super interesting to our customer.
The turbine to power your battery pack. Are you talking about a micro turbine? Are you talking about like a small turbine? The
Yeah.
size of the turbine, is it a micro turbine? Is it one of these small? You've got some, auto aviation, some new business jets coming out. They're using small Williams engines. How
Yeah.
big is the turbine you're talking about?
Yeah, look, for the prototype, the two-seat EL2, we built our own, totally vertically built, developed, and flown now for 2 years, hundreds and hundreds of operations. We just used a small solar helicopter turbine, mated it to our own internally developed generation system. So as we look now to the product, the EL9, we're talking to a couple of core manufacturers, all of whom start with baseline turbines, most coming out of the helicopter space, not all. And so they have slightly different approaches to, the kind of turbine that they're using. We have partnered with Safran to build something called the TG400, which is the turbo generator that will power. It'll be the prototype for what they'll also later do as a larger turbo generator, I expect. But the TG400 is a good example because it's built on the Arano helicopter engine. And so step by step, you can see all the TG players starting to look at different ways to find that underlying turbine capability. GE, Beta, our friends up in Vermont, just recently announced that they're going to do some turbo generator work together, and they're building off the GE T7. So you got, again, you kind of see people looking at the existing turbine environment and then trying to match the right SHP horsepower to the right kilowatt generation that's needed for the system, and they're all winding up in slightly different spots. So whether it's 400 kilowatt hours, 600 kilowatt hours, a megawatt, you kind of see the field starting to take shape.
I love it. Let's shift gears a little bit. John Langford
Yep.
from Aurora Flight Sciences played a
Yep.
big role in getting started.
Yeah, our chairman,
Uh,
our founder.
yep. What's it like developing an aircraft in the VC environment? I mean, obviously, a lot of investors, a lot of you're out there attracting benefits, challenges. I mean, the big OEMs aren't doing this,
Right.
or they say they are, but they're not. You guys are. And what's it like trying to raise money and do this all at the same time, and the challenges of that, but the benefits of a little bit of autonomy and the ability to say go.
Yeah, I mean, look, John's not just a super engineer with an extraordinary pedigree and track record of developing dozens and dozens of airplanes over time, but he's also an extraordinary gatherer of talent. And so his collaboration and partnership over decades with people like John Hansman and Mark Drayla at MIT have been core to what we do. And then there's a whole generation of extraordinary younger in their career engineers that John's worked with at Aurora Flight Sciences and beyond, and many of them who he's attracted into Electra. And so the talent base is rich, and it's a real gift to be able to start there. To do something as novel as this, as transformative as this, requires that kind of just great, careful, top of the talent ladder thinking, and that's what we're getting out of the team. So, real kudos to that starting point. The moment for the industry, you're talking about where does VC meet with that kind of prototyping, high innovation, edge of the what's possible domain. Well, that was a big part of the conversation John and I had before I came in, right? Which is John said, "Hey, I've been prototyping airplanes for generations now, and what we really want to do here is build an airplane production company." And for me, that was very attractive, right? The opportunity to come in, bring my 17 years of experience at Big Boeing, thinking about what an airplane production company should look like, and beginning to build up the foundation for that here at Electra. And so that's been very much the shift and the pivot. We announced the product. I came in August 2024. We announced the product in November 2024, and have been off and running at it since. We just will have our PDR next week. We'll have our CDR in 26. We'll aim to do first flight in 27, which would get us to a TIA in that 28 timeframe. So, relative to the VC community that looks at a pathway like that and asks, how and whether to fund it, two things stand out. One thing that stands out is this is not SaaS, right? This is not software. This is something that has a longer cycle. And so it takes investors who want to put patient capital to work and who want to be part of generational change. Like that's number one. The second thing that really stands out to me is it's an investment opportunity that clearly has legs to grow, right? We're super focused, maniacally so, on the 9-seat airplane, but there's no doubt that this tech wants to grow into other spots as well. The ability to do the electric blown lift that's at the core of our ultra short capacity has interesting value prop for other kinds of platforms. And it may not be ultra short performance. It may be using the excess lift that can be generated to go to smaller wings that create reduced drag and give you a lot of fuel efficiency at larger scales. So the trades that are out there in the future kind of excite the investors because they know that we can build a business case and sell it on just the 9-seat airplane. And there's all this upside that's not priced in. So it's free upside for them. And you asked the question, like, what does it look like to do this small airplane thing? Well, having sat in the seat, right, as a chief strategy officer at Boeing and had to think about capital allocation, it's really difficult to allocate capital from an Airbus or an Embraer or a Boeing to a small airplane system like this. The market's just so small, it doesn't really move the needle on what you're doing on a quarterly basis. And there's an awful lot of value to be had from driving the product forward at the edge of the narrow body and the wide body markets that are their bread and butter. And so, I think it really takes small companies like this with the support of capital that's out there in the market to harness some of these new technologies that otherwise I don't think we'd see come through. And that's one of those little seams that you kind of see in an industry, and that it's necessary to be invested in so that it can expand and become more than a seam and turn into a flowing river. And that's what we're working on.
Is some of your capital coming from the bigger OEMs who are a little bit more curious, or is it more Silicon Valley type, VCs, or a little bit of both?
Yeah, it's a total combination. So we have received investment from Safran, from Honeywell, from Lockheed. So those are sort of some of the big, the guys you think about as primes or tier one suppliers. They're involved for a bunch of different reasons, right? Strategically want to stay close to the technology, part of the supply chain with us, lots of great different collaborations there. We've also received capital from a number of venture capital funds. We've received capital from some growth equity funds, which now start looking like crossovers. And we've received money from some institutional funds, really big institutional funds. And so it's a great shareholding, really supportive investors, but there's no way to sort of, capture it in a word because we've got a lot of different flavors right now of participation.
Yeah, I get it. So talk about you talked about something, kind of your talent. Your talent pool is going to be different. You've got some brilliant engineers in there. I take it what's the bigger focus? Less aerodynamics, more software, a lot of more software, more power plant. How are you attracting the best and the brightest to Electra?
With a big mission. With a mission to change the way aviation's done. That's what everybody here is here for. Everybody is mission minded. We all believe that there's a better way to do this, and that direct aviation is the answer. And so we're all fully subscribed. That attracts an amazing talent pool. In terms of the types, right? I'll call it the digital lead versus the classic, aero analysis. The answer is it's both, and frankly, they're merging more than ever. And so you see people combining domains in new ways. People who really understand airplanes and really understand programming in the digital side of things. We have a fly-by-wire system in a 9-seat, turbogenerator propeller airplane. Like that's novel. Right. I mean, fly-by-wire to this point has historically been all about jets. Okay. Right. Very, very different thing. We take 8 propellers and we give them completely differentiated propulsion. So each propeller is receiving its own propulsion command. The flight control computer is doing the integration. It's not a pilot with 8, thrust levers. It's a single FCC doing the work to integrate that against the flight control logic. And all of that is directly integrated into all of the actuating parts, right? So the rudder, the ailerons, the elevator. So the airplane's FCC is really receiving almost like, think about like point and click commands from the pilot, and then optimizing the path, developing roll, pitch, yaw, right? All the dynamic motions of flight out of all those different capable inputs, the different 8 propellers with differentiated thrust and the actuating surfaces together. That's a software challenge. And so, what we've got here is a really fun hard tech, deep tech intersection. It's hard tech, deep tech because it's industrial, it's physical, it's metal, but it's software based. I mean, if you're going to fly an airplane at less than 20 knots, which we've done, and do it with high precision, right? We haven't yet stalled the wing. You got to have a computer that's on its game, and developing that computer and putting it on its game is part of our challenge.
Is that where what skills do you find in the most obviously software is huge. Software engineers, is there enough software engineers out there in the world to do what you guys want to do, or is it the aerodynamic? It's
never enough, Craig. Never enough. I mean, for us, we're on the hunt still for more. Like we're on the hunt for more. And the challenge is, as I said earlier, it's getting people who can integrate the software and the aero sides together. We create really special professionals here because of that integration.
How long do you think the timeline is for the market to really understand? I love what you talked about, kind of this network, the network flying. 9 seats, but hey, look, we'll bring them in from a lot of. Nobody can predict the future, but are we, a couple years away from this? Is there going to be an aha moment for the industry? Is there going to be an aha moment, for the industry where they go, hey, wait a minute, this is we could do that. We could do this. Is it going to be a gradual thing? What a lot of noise. How long to break through the noise? I want to say, hey, look, in an industry that moves slow. FAA, big companies,
sure.
Whatever. In an industry that moves a little bit more slow and cautious, does it just have an aha moment? Is that?
I think it was Andy Grove, from Intel way back when, who said that change in a big enterprise was like a ketchup bottle. You pound it on the back side of it. Remember those old glass ketchup bottles? and you pound it really hard on the bottom, and it's like nothing's coming, and then all at once it all comes out.
Yeah.
I expect it's going to be a little bit like that. It's going to be, all at once, because what will happen is that a lot of the infrastructure will be put in place by people who get it, but it won't be visible to the outside world. It's like an iceberg being built under the water surface from the bottom up. And then at the very end, the little peak pops through. And everybody
Yep.
goes, "Oh my goodness, like what's that doing there?" Well, you just didn't see it. You didn't see that the Department of Transportation is working so hard right now on the EIPP and all of these project demonstrations. You didn't see that there are all these propulsion companies developing turbo generator product. You didn't see that there are all these operators that are starting to negotiate not just routes with us, but infrastructure with people who they want to be able to use as access points, for their ultra short. You didn't see that there are conversations out there happening, between the developers and the airports, and people thinking about air routes and making sure they are deconflicted with airspace, ramp space, gate space of the big airports. Like, there's all this work happening. Very little of it's visible. And when that peak just pops through the water, everybody's gonna be like, "Oh my goodness, that came so fast." And most of us are gonna be like, "I want to go take a nap because I've been working my butt off for the last 10
Yeah.
years." And that's kind of the
Yeah.
reality of what we're doing.
I got it. Look, we've got an administration now, which is really very forward thinking. Sean Duffy, very forward thinking. The FAA administrator is very forward thinking. I got to think is the DoD on board going, "Yeah, hey, show us more," jumping up and down with excitement, saying, "Yeah, we can, let's think about this a little bit more." And they cheering me on, or
DOD's. Yeah, I mean, look, I think the DoD has taken a very strong pivot towards opening its doors to defense tech. Right. I mean, you got to remember, it was only 10 years ago that most of the technology companies in California refused to work with the Department of Defense. Right. Those of us who've been in the industry remember seeing that. And it was kind of shocking. Like, we're talking about national security that matters, but there was just a refusal to get involved. I think Ukraine changed everything. When Russia invaded Ukraine, a lot of people said, "Oh my goodness, the world is a more dangerous, more difficult place than we realized. We need to make sure we're using our capabilities and our technology to protect and defend our people, our nations, and our allies." And that opened up, I think, a readiness, a willingness, even an eagerness by a lot in the technology community to develop tech that could be part of that very important national security mission. And you could see DoD responding to that. Right, the early days investment between and behind things like DIU, Defense Innovation Unit, right, the effort in the Air Force at AFWERX, the effort with Army Futures. Like, there's been a real growing focus on how to organize and fund efforts that bring technology in to the Department of Defense. What we're doing with the ultra short airplane is a classic case. Right. So the government has been a big supporter. We've received about $50 million in obligated funds to develop the ultra short, the EL2 prototype, and now pushing toward the EL9. So their interest is driven entirely by, I think, that runway independence, that runway agnosticism we talked about, as well as the understanding it has a lot of additional missions. It'll be able to fly, onto and off of barges and commercial ships at sea, like all kinds of just interesting, fun stuff. That will, I think, really open the doors in a lot of ways for the development of the whole system, because I think DoD will ultimately probably come first. Their ability to take airplanes and test them with us, do validation, testing, familiarization, training, even before we get to certification, is a real unique value prop that they have to offer for technology development. And so I think us doing that together is going to be part of the think about that like the leapfrogging on the calendar.
I love it. All right, last time I'll put you on the spot now. Last question. You got a pretty unique background. You got a unique background. You're not your classic aerospace guy.
I know, right? I don't, God's grace. God's grace.
Lawyer on the board of Procter and Gamble. Yeah. A couple of years with Boeing. You've seen things from different perspectives. Industries from different perspectives. How do you bring all that together? I mean, obviously you got a lot of enthusiasm towards Electra and what's happening in the world. With your company, how do you bring who do you go to when it's like, "Hey, I'm running into a challenge. I'm thinking about some things differently." How do you blend all that experience you've got into your role as a CEO?
Yeah, phone calls, phone calls to people who are a lot smarter than me, been around the block a lot more than me, and have better backgrounds than me. I've been really fortunate to be a part of some great teams over the course of my career. And there's nothing better than when a team is really working well together and in swing. Do you ever remember the movie Boys in the Boat, or the book if you read it?
Absolutely.
Yeah, so I had the good fortune to just, for half a second, I rode crew, right? Just a little window of time when I was in university. And what an extraordinary training ground for what it is to do hard things together with others, where you're completely dependent on the boat being in swing. And it's all about, the 8 men rowing together, every blade exactly in the water at the exact same time, pulling hard, exiting at the same time, feathering over the water, back in, repeat. And that mindset, like what a great team and a great swing is, always stays with me. And when I experience it, it's just the most joyful thing in the world. So really, I mean, I said it earlier, and I meant it. It's God's grace to be able to be in this amazing industry with great people. And right now, for me, the real challenge is developing a team that can have great swing. We're not there yet. We're young, we're scrappy, we're all going 1,000 miles an hour, wearing 20 hats. But boy, I can see it. Like, I have the vision. I can see that we're going to be that team with great swing. We'll keep developing. We'll keep adding people. It'll keep changing. It'll be hard for a lot of years. But we know what we're going to. We know what good looks like. And I think that's where I'm really fortunate to have a great set of mentors and folk I can reach out to and ask questions of when I'm confused or when I've got something that just feels too hard. That's why the phone really is the most valuable tool in the toolkit for reaching into the different experiences I've had. I grew up the son of a bunch of academics. And I always knew I was a little bit of the black sheep sitting around the table, because they were like all the PhDs, like they had big ideas. And I kind of just like getting stuff done. But my dad was a political scientist, my sister, political scientist. I loved what it meant for government to order our lives, improve the posture of communities, create space for us to flourish. And so the intersection of business, which is about practically building value for customers, right? Really getting stuff done for people, in aerospace, which is the most fundamentally, I think, collective and government-driven industry out there, national security interests, aviation's owned by this nation states and half the markets of the world. Like, it was this perfect mating of these two passions I had from my young age. And so when I got to Boeing in 2007, I was like, oh my goodness, it was complete serendipity that I arrived. It wasn't a plan. I had a mentor who became the general counsel and asked me if I'd come in and work with him. But once I got in, it was like, well, this is obvious. I don't know how I missed it for the first 15 years of my career. Let's go. And it's been glorious ever since.
I love it. Hey, Mark, let's do this. Let's cap it here.
Yep.
I'm going to look forward to having you on in like a couple of months when you get you get to the next gauge. We're going to talk about the progress you guys are making. Love what you're doing. Love the airplane. Love the project.
Love it. Craig, I look forward to that. And it's great to get to know you through this podcast and our other conversations. And thanks for doing what you do for our industry. It's a team sport, and you really are part of helping us grow that.
Thanks for coming on. It's exciting. Thank you for being here today.
You're welcome. You're very welcome.